everyone. Good morning. Very good morning, all of you. Good morning, everyone. Hope you are all doing well. Right. So, all of you had your everyone had your lunch or not? Why? Yeah? Okay. It is visible in the black color. Why? It was in the green background, but it is visible in the black color. Here, what happened to this? The color. Okay. Right. So all of you, welcome to Unacademy. Let's crack it, right? Everyone, get ready to crack, all of you. So these are all GATE 2023, GATE 2024 toppers. Those who are secured AIR 1 from Unacademy. Yeah, Pavan, good afternoon. Lunch over, Pavan, or not? Right. So this one, this flat 50% off on your GATE subscription. So it will be available for this limited period time only. So don't miss this opportunity. Use this opportunity and subscribe to this pleasant iconic courses, everyone, right? So that RP Civil is the code you have to use, right? And you can start your GATE preparation at which one? This 9,999 rupees only. If you are taking the plus subscription for this 9 months, it is at 9,999. Iconic subscription for this 9 months, it is at this 15,999, right? So don't miss this opportunity. Anybody is willing to start your preparation for this GATE and ESC 2025, you can start from now itself, right? And also from 13th July, these are the new batches starting, right? That Pratishta batch for this GATE ESC PSUs civil engineering, and it will be started, surveying will be started by Jaspal sir at 11:30 AM, you can say, okay? And what is the code you have to use, right? RP Civil is the code you have to use, okay? Now for 2026 aspirants also, this is your Shikhar batch. It is starting on same 13th July only, surveying only it will be starting, right? So don't miss this opportunity, everyone. Now, so these are all the books, right? Whenever you are taking iconic subscription, at these books you'll be getting printed books delivered to your home within 15 days of your subscription, right? So this is my profile, you can follow me at which, and this is a referral code you have to use, right? RP Civil. Now this coming to this highway quick revision series, right? Up to which part we have discussed, if you just remember? Do you remember in the last class, right? What is that part we have discussed in the 26th session, right? What is that we have discussed? Do you remember on 5th July? So this model speed, right? That 98th percentile speed wala traffic density or this concentration definition, right? The relation, fundamental relation between this traffic flow or this volume, and which one you can say that a traffic density and this traffic speed, right? These three fundamental relations, it is these three fundamental parameters, the relation is given, you can say, if you just observe, right? Is it right? Now, so what is that? This fundamental flow model, that is your green shield model also we have seen, if you just observe, right? So by default, if nothing is mentioned, right, which model we have to use, you can say that a green shield model only you have to use, if you just observe, right? It's not right. This is your 297th point, and Q maximum V equal to Vf into that K equal to Kj into, right, like that you have to write them. So 298, right, the flow 298 points gets over, yes or no? Now we'll be going on to this continuation of this. So traffic signals will be starting, right, once that part is over, okay? 298 is over, right? It's not 298 is over, and 299 we are going for. So this is your first slide, you can say 299th point, if you just observe, right? Is it right? 299th point, you can say. Now what is that traffic flow model, if you just observe? That traffic flow model, right? What is that, you can say, if you just observe? That is your Underwood model, na? Underwood model, right? So Underwood model is nothing but your which one? This exponential model, na? Underwood model is nothing but your exponential model, right? What is the meaning of this exponential model, you can say? So this fellow Underwood has given the expressions in terms of which one? This exponential function, na? So what is that? V is equal to, you can say that V is equal to that Vf into e power minus k by this kj. So v equal to that Vf into that e power minus k by this kj, you can say, is na. Now, so what is that you are having again? So that q equal to how much you are getting, that is your kv we are getting. And what is that q maximum, that is very very important or not? Q maximum is equal to, what is it you can say, kj into, so in case of this green shield model, what is the q maximum, you can say kj by 2 into that Vf by 2. So here what is it you can say, kj into what is that, Vf by this e na. So this is your Kc into that Vc, right? Kc is nothing but your which one? Density at this what? Kc is nothing but your density at this capacity. So Vc is nothing but your which one? Right? What is the Vc you can say? What is the Vc you can say? If you just observe, Vc is nothing but your velocity at this which one? Right? Velocity at this capacity conditions, na? Is that no? Right. Right. So now, so what is that next model? What is that another model? Next model, if you just remember, any idea about this other models? What is another model you are having? Greenberg model, na? So no, that is your traffic flow model, right? Traffic flow models, right? What is that you can say? That is your Greenberg model, you can say. Greenberg model is also called as which one? This is a logarithmic model. E is nothing but your e value only, no, 2 point value, right? How much is that e value you are having? What is that 2 point? How much? Tell me. 2.72 or 2.718. You will be having the t value now. So do you remember that? Log to the base e will be writing exponential value, e value. So logarithmic. Is it clear, Pawan? It is your logarithmic model, you can say, right? So whenever it is that a logarithmic model, right, what is the equation of this logarithmic model you are having? If you just observe, yeah, 2.7, 2.3, you can use anyone, right? 2.718 is the actual value of e actually. Okay, now, so what is it you can say? If you just observe that v equal to, what is it? V equal to that Vf into what is that? Log kj by this k. So here what is that you can say, in case of this underwood model, at this q equal to that q maximum, what is that density? Density is equal to that geom density kj. And what is that velocity? Velocity is nothing but your free flow velocity divided by this e, you can say. And here what is that? V equal to that Vf into log kj by this k to the base e, if you just observe, right? Is not? Now what is that q equal to that kv equal to k into that Vf into, what is it you can say, log to the base e, right? What is the functional value of this log? Kj by this k only, now that is your kj by this k, you can say, right? Like that. Is that clear? Now what is the q maximum you are getting here, if you just observe? So from this there was a question in the gate, right? In 2012 it was asked, right? Q maximum is equal to which one? This, that is your kj by e into what is that? Vf, right? So what is that kc? K corresponding to capacity is what? Vf by a. What is it? Vf Vc, right? Vc is nothing but your free flow speed, right? Like that. Yes, over. Yours over. Now at q equal to that q maximum, what is that at this maximum flow or this capacity? So what is that k value, you can say? That k value will be that kj by a. And what is that v value, you can say? That is your Vf value, right? Like that will be having, right? Is it clear? So this is about your which model, you can say? That is your Greenberg model, right? Greenberg model, or you can also call it as which one? Tell me. Greenberg model or which model? Logarithmic model, right? Why you are log to the base e? It is not to the base 10, okay? Pavan, it is to the base e only, right? It is not to the base 10, right? You have to be very, very careful, right? Got it? Right? Okay. So note this and tell me. Then we'll move on to this traffic signals now. The traffic signals part will enter now. Done? Noted? Others also noted? Everyone? Right. So whenever you are going for this traffic signals, right, generally which type of colors will be having in this traffic signals? Tell me. What are the three different colors will be having in the traffic signal? You'll be having this three colors, right? One is your red. This is your 300, 301 point. What are the three different colors? Tell me. Top traffic signals colors, right? What are these different traffic signals colors will be having? Tell me. What are the three different traffic signal colors you will be having? If you just observe, tell me. Hello, somebody. Anyone having idea or no idea? Red, amber and this green, you can say, right? So what is that? Red, amber and this green, right? So whenever you are having this red color, right? So what is the meaning of this red color? You can say that is the meaning of this is your stop, na? Yes or no? The meaning of this red color is your stop or not? Next, what is another one? You can say if you just observe, that is your amber or this yellow or this orange, right? What is the meaning of this? Is it visible? Amber or this yellow or this orange, is that color visible or not visible? Okay. So what is that? Okay, green, right? Whenever that green comes, na, right? What is it? You can say that green comes, right? What is it? You can say go, right? What is that? A red, amber. Okay, I'll be writing that amber, yellow or this orange, right? Any of these three colors we can use, right? What is that? Get ready to stop. Okay, so red is going to come after green. You have to provide this amber, na? Red is don't stop. If you don't stop, na, directly you will be giving shake hand to 𝐂𝐚𝐴, is na? So you have to be careful. So that is what, if you stop, na, if you get ready to stop, na, you will not be meeting 𝐂𝐴MRAJ. Otherwise, if you are not stopping, na, if you are stopping, na, what is it? You can say if you are stopping before red comes, right, you will not be meeting the 𝐂𝐴MRAJ. You can say if you just red, is it right? Is na? Is it clear? Right? So what is it? You can say after green, right? Get ready to which one? This is stop. Get ready to stop, or what is it? You can say. Can we say it as this clearance time? So during the green time we are moving on the intersection, and we have to make we have to keep the intersection clear. Is na? We have to keep the intersection clear before the red comes, na? Before our red signal comes, and we have to keep the intersection clear, right? What is that we need to do? Tell me. If you just observe it, how we need to do? So after meeting 𝐂𝐴MRAJ, nice meeting you. Velostha Ema be like, yes, yes, right. Yes, you can say absolutely correct. Okay. Yes, absolutely correct. Okay. Right. Right. Now you have to be very, very careful, right? So if you don't want to meet 𝐂𝐴MRAJ, na, you have to stop. You have to stop your which one is vehicle, right? That is very, very important, right? So clearance time, right? And you can also get okay. Is that clear now? So these are the different times you are having if you just observe, right? So which one will come after which one? You can say if you just observe, first green will come, na? So no, that green will come. After this green, right, what will come? That yellow or this amber will be there. Generally we'll call it as this amber time. After amber, right, what it will come? That red will come. And after red, right, what is that? You can say that green will come. You can say if you just right, isn't it? Green, amber, red, right? So what is it? You can say green, amber, red, green, amber, red, green, amber, red. You will be having if you just right, isn't it? So is that clear? So that colors, right? So that will be repeated, na? Yes or no? That will be repeated or not? Yes or no? That will be repeated for many number of times. You can say if you just observe, right? Isn't it? Now, if you are considering generally there are two phases, right? Let us say this is your phase. Okay, I'll just write this phase 1 and this phase 2 like that. Phase diagrams will be seeing. One second. It is not getting erased. Here. All link is erased. Arey Baba. All link is erased now. All link is erased. Control Z. Arey. Control Z if I do, it is not coming up. Okay. Okay, right, again I have to write this. 301. Arey Baba. So what is that 301? Traffic signals. Huh? Arey yaar, what it is happening here? It is already there on the back side. Arey. What is happening here? One sec. Just let me. One sec. Okay, we'll go for this 301. 300 gets over now. So 301. Yeah, Yamraj got angry because we are playing jokes on him na. Traffic signals and this colors, right? So what is that? You can see that is your green color if you just observe. That is your go. Red color if you just observe, right? What is that? You can say red color is your stop if you just observe. That is your amber or this yellow or this orange color, right? What is that? You can say. So it is your get ready to go. Sorry, get ready to go or get ready to stop. Get ready to stop na, or get ready to clear the intersection na. Clear what? Intersection or not? Yes or no? Get ready to clear the intersection and before the red is going to come. Yes no? So like that we'll be having if you just observe, right? Is it right? Now what is that we'll be having? That green will be there. After green which will come? That amber will come. After amber red which one will come? That red will come. And after red again green, right? Green amber red, green amber red, green amber red, or red green amber, red green amber, red green amber, or amber red green, amber red green, amber red green, right? Anything is repeated na, that repeated portion is called as which one? Cycle if you just observe, right? What is that a repeated portion? You are calling it as cycle if you just observe, right? Now if you just try to draw this phase diagram. So whenever you are having this phase diagram, right, let us say just for two phases are only there, right? Yes, na? Phase 1 and this phase 2 if you just observe. So here what is that? You can see if you just observe, whenever green is there in the first phase and after the green which one will come? Amber will be there in the first phase, right? When this first phase, so during this green they can move comfortably, during amber also they can move to clear the intersection na? So during amber also they can move to clear the intersection, right? During this green they can move, during this amber also they are in the motion. When the first phase vehicles are in motion during this green and amber, second phase vehicles, tell me, these second phase vehicles should be which one? Tell me. These second phase vehicles should be moved or these second phase vehicles should be stopped, you can say. This second phase vehicles must be stopped definitely, na, right? If you do not stop the second phase vehicles, already first phase vehicles are on the road. If you are entering the second phase vehicles also, accidents will happen, right? So this second phase vehicles must be having this red, right? After that, right, what happens? Tell me, these first phase vehicles after this green and amber, they have got this red. During the red for this first phase, what the second phase vehicles must be having? Tell me. The second phase vehicles must be having this green and this amber na. So G2 and this A2 you can say if you just observe, right? Again that will be repeated or not? G1, A1, So here corresponding to that, right, what is it you can say? This is your R2 you can say. Yes, na? This is your R1. So what is this for? This is your again this is G2, A2. So like that, this process will be repeated continuously or not? This process will be repeated continuously, right? What is that repeated portion? If you just observe for this first phase, green, amber, red, next green, amber, red, next green, amber, red, right? This is a portion repeated, so you call it as a cycle. For this second phase, that red, green, amber, red, green, amber, red, green, amber is repeated, you call it as this cycle. Or you can also call it as this green, amber, red for the second phase also. Or you can also call it as which one? This for this, right? Red, green, amber also you call it as na? Is that no? Right? Right? So what is it? Tell me. So this is how it will be happening na? Is that no? This is red, green, amber, red, green, amber, that red, green, amber, it will be happening na? Is that no? So that repeated portion is called as your cycle length or not? Everyone, right? Repeated portion is called as your cycle length, you can say, right? Note this and tell me if you just observe. Note and tell me. Then we'll move to the next. Done. So 303 point we'll go for. So now what is that 303 point? You can say if you just observe, this is your traffic signal. Yes or no? What is that cycle length? You can say that cycle length C is equal to which one? How can you write that cycle length? You can say if you just observe, that is your green of any phase, ith phase, plus this amber of this ith phase, plus this red for this ith phase, you can say, is na? Isn't it? Green for this ith phase and this red, amber for this ith phase and this red for this ith phase, you can say, right? Any phase, right? Now you can also write this as which one? This is C equal to first G1 plus this A1 plus this R1, or with respect to the second cycle, right? What is it you can write? With respect to the second cycle, right? What is it you can write? R2, G2, A2, na? Yes or no? What is it you can write it as? That is your R2 plus this G2 plus this A2. So now this is your first phase timing, this is your second phase timing. G1 plus this A1 is the time allocated for this first phase vehicles to move, na? That is the first phase time. Next R1. So during this R1, second phase vehicles are moving. So can we replace that R1 is equal to that G2 plus A2? So that is your G1 plus this A1 plus what is that you can say? That is your G2 plus this A2. Here also can we write the cycle length in the same manner? R2 as which one? During the ready time for this second phase, first phase vehicles are allowed to move, na? So G1 plus this A1, R2 will be equal to which one? This G1 plus this A1, right? G1 plus A1 plus this G2 plus this A2, you can say, right? Isn't it? Is that clear? Got it now? Clear? So like that, what is that? You will be having this if you just observe, right? Isn't it? So therefore, can we define this cycle length? C will be equal to phase times, right? Phase 1 time plus this phase 2 time. Phase 1 time plus this phase 2 time, na? Yes or no? So can we say that a cycle length will be equal to that sum of this phase times? Can we define it like this or not? Sum of this phase times, you can say if you just observe, right? Is it right? Now shall we go on to the next? So that is your cycle length definition you will be having if you just observe. That is your which one? This is cycle length definition you can have, right? Now what is that cycle length formula if you just observe? Optimum cycle length formula if you just consider, right? What is that optimum cycle length you can say? What is that optimum cycle length? Tell me if you just observe. What is that optimum cycle length? Tell me. That optimum cycle length means least possible cycle length. That too with what conditions? Tell me. It should be allowing all vehicles. Nice, sir. That is right. Optimum cycle length as per which one? This Webster's formula. Na? As per this Webster's formula, you can say if you just right. Is it right? What is that optimum cycle length as per this Webster's formula? C naught is equal to that 1.5 L plus 5 divided by which one? This 1 minus this capital Y, right? 1.5 L plus 5 divided by which one? This 1 minus this capital Y, na? So that is your, which one you can say? That is your optimum cycle length if you just observe, right? Isn't it? That is your, which one? This optimum cycle length you can say, right? Yes, now note this and tell me. Then we'll move to the next once it is over. Because I am having class at 2 o'clock. I have to close it now. Again at 4 o'clock class is there. 4:15 one more class is there. Done? No. So what is it you are having? That capital, that L is nothing but your, which one? This is a total lost time per cycle. L is nothing but your, which one? This total lost time, which one? This per cycle, right? So what is the total lost time per cycle? You can say that is your L is equal to that 2n plus this R. So what is that 2 seconds if you just observe? It is your startup lost time per phase, na? It is your startup lost time per which one? Per phase you can say if you just observe, right? And what is that n? You can say n is nothing but your, which one? This is a number of phases in a cycle, na? N is nothing but your number of phases in cycle or not? Now, so what is that R you can say? That is your clearance lost time, right? What is it you can say? It is your clearance lost time. So to make this clear, we have to keep which one? This every phase with a red signal, right? Clearance lost time, or you can also call it as which one? This all red time, right? What is the meaning of this all red time? You can say all red time is nothing but your all phases are having this red, na? All red time per cycle, right? That is what you are having, right? Now what is the capital Y? You can say that a capital Y is nothing but your sum of this y1 plus this y2 plus this y3 plus this, so on yn, like this n phases are there, na? What is that? q1 by this s1. y1 is nothing but your q1 by this s1 plus this y2 is nothing but your, which one? This q2 by this s2 plus so on, which one? This qn divided by this, which one? This sn if you just observe, right? Isn't it clear? No. Therefore what is that yi? You can say small yi, that is your qi divided by which one? This si, right? What is your qi divided by this si? This is your normal volume, or what is it you can say? Critical lane volume, right? Normal volume or critical lane volume of which one? This phase I, okay, divided by. So whenever many lines are there in a particular phase, all these lanes vehicles are allowed at a time. But which lane we have to consider? Only one lane which is critical, which is having this more traffic we have to consider, right? So what is it you can say? Saturation volume of which one? Critical lane. That lane only, right? Saturation volume of this critical lane of which one? That phase I only, right? So can we say it is your ratio of which one? This is a normal stresses to this saturation stresses, no? So capital Y is which one? This is sum of the ratios of this normal flows to this saturation flow, or not? Sum of this flows of this sum of the ratios of this normal flows to the saturation flow, right? Like that. Okay. So next we'll be having this next class on the next day, Wednesday, right? Shall we close the session? I'll be closing the session. Thank you. Have a good day, right? Thank you.